2.
Hi all, I'm Pushpalatha KR. I work for HP. I'm part of W WebPrint platform. So today I'll be talking about predictive statistical data analysis for product stability and capability. So with so much of data in the system and the environment, it becomes difficult to understand the product stability and capability. As product capability cannot be understood with the used data, it becomes difficult to improve and sustain the reliability and the scalability. So data-driven problem solving is an iterative process from practical arena to the statistical arena and then returning to the practical arena with a conclusion. So when a sample data is considered, we always take in numbers. So it's very difficult to interpret the numerical data. So when it comes in graphs, we can actually identify what is the problem and where exactly we can fix the issue. So here, histogram is one such graph where the distribution is assumed to be in a normal distribution, and this distribution is controlled, is normalized by central limit theorem. And as the sample size increases, the mean variation tends to be normal as compared to the original distribution. So there is a trend chart where we actually show like what is the expectation for the customer satisfaction rate with the goal with the goals defined and the actual scenario, the present scenario. So with this, we can actually decide the customer satisfaction rate. So these things may be difficult to interpret unless we plot it on the histogram. So to understand the product variability and the product uh, uh, stability, what we have to do is we need to measure the center, and this is done through statistical process control chart where it is defined by the mean, variation, and the mode. So the to measure the center, it is done through central limit theorem where we actually identify by calculating the mean, which is actually the sum of all observations by the total number of observations, and the median and the mode. And the variation, the process variability is measured by the variance, the range, and the standard deviation. The range is the difference between the max and the min value, and the variance is actually the average square difference between the mean and the individual observations, and standard deviation is the positive square root of the variance. So through these things, we can actually plot the graph where we can measure the center and the measure the spread, the distribution through variance. So how exactly we do the variation analysis is through the statistical process control charts. There are many charts, and here we use a statistical software called as Minitab software. So using that software, we opt for the statistical process control charts, which are considered to be more powerful than the normal trend charts or any other charts. So to leverage the scale variability, this is the best suited chart. And control limits help us distinguish signals from the noise. Uh, the random control charts are considered to be more powerful to evaluate. Hello, Diana?
Yeah.
I'm sorry. I mean, I'm getting a call. I'll disconnect this. I'll switch off my phone.
Okay.
So I should start from the beginning or what?
It's up to you, but I can go in and edit this part out if you want.
Okay. I think I'll start from the beginning otherwise.
Okay. Yeah, go ahead and just start over, and then what I'll do is I'll just edit the whole first part out.
Okay. Sorry, I forgot to switch off my phone.
That's okay. Don't worry about it. So you can go ahead and restart at any time.
Okay. I'll start now.
Sure.
Hi all, I'm Pushpalatha KR. I'm part of HP. I work for WebPrint platform. So today I'll be talking about predictive statistical data analysis for product stability and capability. So with so much of data coming into the system and in the environment, it becomes a very challenging task to predict the stability and the capability of the system. So as a product capability cannot be understood with the used data, it becomes very difficult to improve and sustain the platform reliability as well as the scalability and even the availability. So data-driven problem solving is an iterative process from practical arena to the statistical arena and then returning to the practical arena with a conclusion. So with so much of data, it becomes difficult to interpret, like uh, uh, to understand the capability and the stability. So what we have to do is we need to plot the graph, and the main one such graph is the histogram, and this graph we can actually plot it using a many type statistical software. So with histogram, when a sample of variable data is collected, we can actually find the centering and the dispersion, and this is done uh, to measure the product the stability and the variability. And there's one more thing where we can do is what we can do is by plotting the trend chart will actually give you the actual customer satisfaction rate. So with the trend chart, we can actually find we can actually plot define the goal, and whether we are meeting that goal and all, we can actually find it through the trend chart on the a scale can be like a weekly basis or on the monthly basis. So based on that, we can actually see whether we're able to satisfy the customers. So for that, we need to measure the center. Like I said in the previous slide, in the histogram, we can actually find the center as well as the distribution, the spread of the process. So to measure the center, we should assume the distribution should be a normal distribution, and this is one of the important thing to consider while measuring the center. And the normal distribution is approximated by the central limit theorem, where we consider, like, as the sample size increases, even the mean value tend towards the normal irrespective of the original distribution. And to actually measure the spread of the distribution, we need to have the to measure the center, it's done by the mean, median, and the mode. The mean is the sum of all observations by the total number of observations, and the to measure the spread, it should be done through the variance, the range, and the standard deviation. Range is difference between the maximum and the minimum value, and variance is the average square difference between the mean and the individual observations, and standard deviation is the positive square root of the variance. So through these values, we can actually measure the center and the spread of the distribution. So coming to the analysis, the variation analysis, this is done through the statistical process control charts. So statistical process control charts provide the better leverage to reduce the variability. So control limits help us distinguish between the signals, like I showed in the, like you're seeing in the graph, you can see that there are signals, and there are certain signals which has crossed the control limits. So control limits will actually help us distinguish between the special cause variation, which is the signal, from the noise. And the statistical process control charts are actually the most recommended charts when compared to the trend charts or any other run charts, because this will actually evaluate the stability of the variation and the mean based on the data gathering and the analysis strategy. So by presenting the data in the statistical based context, we are able to make better decisions with respect to the managing the process improvement. One of the main significant thing is we are actually avoiding the over control, which actually increases the process variation. So the control limits are actually based on the actual data which are influenced by the sampling, which is again called the subgrouping. The sampling strategy defines the interpretation of this control control chart. So looking at the sampling, so we can actually say that as per the normal distribution, 99.7% of the normally distributed population is captured by the curve, and the remaining 0.3% of the 0.3% chance of finding a value beyond the 3 standard deviation. There's only 0.3% chance of finding a value beyond the 3 standard deviation. Therefore, anything which is beyond 3 standard deviations, we consider that the process has either shifted or it has become unstable. So comparing the plot points to the control limits allows one for us to analyze the probability assessment, and anything above the like you can see in the graph, there is something like upper control limit and the lower control limit. So any data point which crosses the control limits, that shows like the process has become unstable, or the process has shifted its regular phase. So this is where we have to actually focus. And here, once we understand the control limits and the data point analysis, like I showed in the previous slide, what we have to do is we need to evaluate the product stability. So that again we can do it by plotting these control limits, and then see whether we can apply certain rules. Like we need to plot the data in such a way that we can have at least a minimum of 20 intervals of the data points, and then with those data points have these control limits defined. And like I said, this upper control limit and lower control limit can be calculated from the Minitab statistical software for the process control charts for the defined variable data or the continuous data. So with the control limits defined, we can actually see whether uh, for the given set of data, the data point has crossed the upper control limit or the lower control limit. If anything crosses the control limits, that shows the system has become unstable. So the main focus here is like to look into the control limits, and that again is done through the standard deviation. Anything which crosses beyond the 3 standard deviation, that we consider as a unstable product. And coming to the evaluating capability. So to evaluate the capability, what we have to do is we need to understand the CP and the PP indices, like I'm showing in the graph. The CP and the PP indices are actually define the tolerance and the Six Sigma process uh, process. These are the indices for the Six Sigma process and the tolerance. So if the Six Sigma process spread is greater than the tolerance, like in the first part of the second graph, where we can see that the Six Sigma process is greater than the tolerance. That means the index of CP is less than 1, and if the Six Sigma process is equal to the tolerance, as shown in the graph, the second one, the CP value, the index will become 1, and that means there will be a 0.3% of output being, there is a chance of 0.3% of output being defective. And if the Six Sigma process spread is inside the tolerance, like the third part, with room to spare, that means the process is capable of producing few defects. So with this graph and having these indices, which is CP and CPK, we can actually define the tolerance width as well as the Six Sigma width, and with that we can come with the lowest scale limit, lowest specification limit, and upper specification limit, and based on that we can actually see where the process or the product is going, whether the product is actually being capable enough to take this to take the data, or we need to scale further to make it more capable. So this is what it is, and I'm done with the solution, and thank you for this presentation.